Okay. Yeah, valency. So the valency is nothing but that it's a how many number of the electrons present in the valence shell it can able to gain or lose by the atom. That we call it as a valency. So in a period, the valency of the elements increases from 1 to 4 and then decreases from 4 to 0 from the left to right. So the period is nothing but we are moving from left to right in the periodic table. So from, say for example, in the third period, if you are taking from sodium, magnesium, aluminum, so we are moving from the left side to the end of the right side. So that we call it as a period. So when we are moving that one, so the valency of the elements, the first of four elements, it increases by 4, then it will start decreases. Okay. So for example, the second period we have taken for the example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and the neon. So AN means the atomic number. So 3, 4, 5, 6, 7, 8, 9, 10. So now the electronic configuration is, so the 2 comma 1. So the 2 indicates that the first shell. So the first shell can occupy the maximum number of the 2 electrons. So out of the 3 electrons, the 2 electrons we have to place it in the first shell. The remaining 1 electron we have to place it in the second shell. So 2 comma 1. So then beryllium is having a 4. So out of the 4 electrons, the 2 electrons we have to give in the first shell. The remaining 2 electrons will occupy in the second shell. Then boron. So the boron is having the 5 electrons. So out of the 5 electrons, the 2 electrons will be placed in the first shell and the 3 electrons will be placed in the second shell. Carbon, 6 electrons. So 2 electrons first shell, 4 electrons second shell. Nitrogen, 7. 2 electrons first shell and 5 electrons second shell. Oxygen 8, 2 electrons first shell, 6 electrons in the second shell. Fluorine 9, 2 electrons first shell and the 7 electrons in the second shell. Neon, it's having a 10 electrons. So we are placing 2 electrons in the first shell and 8 electrons in the second shell. So the maximum occupancy of the electrons in the second shell is 8. So that is completed by the neon. That is why the neon, whatever the elements which is present in the group 8, so that is always unreactive. They are inert at the room temperature because so these elements helium, neon, argon, krypton, xenon, radon, so this is present in the group 18 or else we call it as a 0 because they don't have the valency at all because they are having completely filled outermost electrons. That's why. Okay. So now in this case we are having a okay, the valence electrons. So the valence electrons is nothing but how many electrons are present in the valence, that is the outermost shell electrons. That electrons can able to gain or lose. So we are not bothered about that how many electrons are present in the inside shell, first shell or something like that, because that is completely filled. That will not come in the picture of the reactions. Only the outermost electrons, the 1, the 2, the which is present in the outside, that only will start losing or gaining. Okay, so now the first one is the lithium, 2 comma 1. The valence electron is only 1. Okay, so now what will happen? The second shell can able to complete by 8 electrons, but here there is a only 1 electron is there for the lithium. So what lithium will do is either it has to gain the 7 electrons or it has to lose the 1 electron. So the lithium will lose this 1 electron and it's having the valency 1. Beryllium. Beryllium is having a 2 electrons, so valence electrons are 2. So here also the same thing. So the beryllium, if it wants to complete the second shell, it needs 6 electrons or else it has to lose the 2 electrons. So gaining the 6 electrons, it's very difficult. So it will lose the 2 electrons. So the valency of the beryllium is 2. Then boron. Boron is having the valence electrons 3. So here also the same thing. So if it wants to gain, so it needs the 5 electrons. If it wants to lose the 3, so the 3, number 3 is very less. So it will do the losing the 3 electrons. Then carbon. Okay. Now carbon is in the midway actually because it's having the 4 electrons in the outermost shell. So what it will do, if it wants to gain the electrons, it has to be 4. If it wants to lose the electrons, it has to be 4. So always the valency of the carbon is 4. Nitrogen. Nitrogen is having 5 electrons, so 5 valence electrons. So in this case, it wants to fill the outermost electrons by 3 by gaining 3 electrons, or it has to lose the 5. So now in this case, so losing electron is higher. So 5 electrons it has to lose, or the 3 electrons it has to gain. So it will prefer only the 3 electrons to gain. So 3. Valency of the nitrogen is 3. So next one is oxygen. Oxygen is having a 6 electrons in the outermost shell. So valence electron is 6. Now here also, if it wants to complete the neon configuration, it needs 2 electrons to gain, and or else it has to uh, lose 6 electrons. So that is very tough, losing 6 electrons. So it will gain the 2 electrons. So valency of the oxygen is 2. Fluorine, it's having a 7 electrons in the outermost shell. It needs 1 electron to complete the outermost shell. So it will gain 1 electron, and the valency of the fluorine is 1. Neon is 0 because already it's completed its outermost shell by 8, because the maximum occupancy of the second shell is 8, that it is already completed. So it is unreactive. It does not have any valency. Always it exists as the monoatomic gas. Monoatomic means it exists as the single atom. It does not combine with any other atom, or it cannot able to combine with the same atom also. So it exists as the monoatomic gas. So now we have completed the period that starts from left to right, the periodic table. Next one is group. The group is nothing but, so the elements we are moving from top to bottom in the periodic table. So we have taken the example group 1A. So the elements hydrogen, lithium, sodium, potassium we have taken. So the AN is atomic number. Atomic number of the hydrogen is 1, lithium 3, sodium 11, and potassium 19. So next one is the electronic configuration. So anyway, the 1 electron is there. It will occupy only in the first shell. 3 electrons are there for the lithium. So the first shell can occupy the 2 electron. The 1 electron will occupy in the second shell. So sodium 11. So 11 electrons, the 2 electrons will occupy in the first shell, the 8 electrons will occupy in the second shell, the remaining 1 electron will occupy in the third shell. So now the potassium. So the potassium is 19 electrons. So second 2 electrons will occupy in the first shell, 8 electrons will occupy in the second shell, the 8 electrons will occupy in the third shell, and the remaining 1 electron will be occupied in the fourth shell. So now if you are seeing in the group 1A, so 1 indicates that the outermost electron number is always 1. So that's why we call it as group 1. Okay, so now the valency for all the elements are 1. So if it wants to lose electron means it has to lose only 1 electron. So that is why the valency is 1. Here also, it's losing electron is very easy because gaining 7 electrons is difficult. So it will lose the 1 electron. So valency is 1. Here also the same thing. So sodium lose the 1 electron and it forms the Na plus. Potassium also losing the 1 electron in the outermost shell and forms the K plus. Okay. So next one is the atomic size. So what is meant by atomic size? So the size of the atom, the radius of the atom. So the radius is nothing but, so the distance between the nucleus of the atom to the outermost shell of the atom, outermost electrons which is present, right? So that distance we call it as a atomic size. So in the period, so as we know that the periods are moving from left to right in the periodic table. So the period always indicates that only the how many shells are there. So if you take the second period means all the atoms in the second period have the two electrons. Sorry, two shells. Okay, so you will not, so the radius will be more or less the same from left to right in the periodic table. But in the group will tell you the outer means how many shells the particular group is having. So once we are moving down the group, every shell will be increasing by one. So first we are going to see about the period. So period we are moving from left to right. So in this case, the atomic size of the elements decreases. So the size will be decreases from left to right in the periodic table because the nuclear charge only increasing. So what is meant by nuclear charge? The number of the protons and the neutrons. So that will be increasing, but not the number of the shells because the electrons are added in the same shell. There is no more extra shell we are going to add. Whatever the incoming the electron, that we are going to place it in the same shell. And the electrons are pulled closer to the nucleus. Okay, so now see here. So now we are going to take the example of the second period. So the second period indicates that these period elements contains only the two shells. So now the distance is from the nucleus to the outermost electron. So the distance will not vary much. Elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, so now in this case, okay, okay. So now in this case, so now this is the lithium. Okay, so the lithium is having the 2 comma 1. So it means that the two electrons are present over here and one electron will be present over here. So the distance from the nucleus to this outermost electrons like this. I'm going to take the carbon. So the carbon is having 4 electrons. 1, 2, 3, 4. 4 electrons in the outermost shell. So the distance from the nucleus to the outermost electrons. See, is there any difference? No, because there is only two shells over here. So the distance from the nucleus to the outermost electrons will be the same. But the inside the proton number will be changing. So the proton number, because we are increasing the atomic number, so the number of the protons only changing, not the distance from the nucleus to the outermost electrons. So that's what we are going to see. So number of the protons increased by 3, 4, 5, 6, 7, 8, 9, 10. So now in this case what will happen is, so this is the lithium atom. Lithium is having the 3 protons and the 3 electrons. So there will be the force of attraction between the protons and the electrons because the protons are having the positive charge, electrons are having the negative charge. So always the protons are attracted with the electrons. That is why we call it as a electrostatic attraction because the positive and the negative charge always it will attract. So here also the same thing will happen. So the carbon is having the 6 protons and the 6 electrons. Now the attraction is still higher than the lithium. So what will happen? The shell will shrink. Because of the force, it's just pulling the electrons towards itself. The protons is having attraction. So when it is 6 protons are attracting the 6 electrons, so it will shrink. So the atomic size will decrease. That's why The atomic size decreases when we are moving from left to right in the periodic table because there will be a more force acting on the nuclear charge. But the shells are not increasing because of that reason. If the shells are increasing, the distance will increase. Now in the group, we are going to consider group. So here the atomic size of the element increases from top to bottom. Yes. So now here we are going to consider the hydrogen. So hydrogen is having only one electron. So this is the nucleus. So this is the distance from over here to here. So this is the hydrogen atom. So now this is the lithium. Lithium is over here. So the lithium is having the two shells, but hydrogen is having only one shell. So this is the distance. So the distance increases when you are moving to the next element in the group. Because as the number increases, the outermost shell also increases. So the distance between the nucleus and the outermost electron increases. So the atomic size is also increases. So the atomic size of the elements increases from top to bottom because the number of the shells increases and the distance between the nucleus and the shells also increases. So the atomic size increases down the group and atomic size decreases along the period. So this is what atomic radius decreases. So lithium is a very bigger one. So it's moving. So the atomic radius is decreasing. But if you check it over here, that shells are increasing by one. So lithium, neon, potassium, rubidium, cesium. So the atomic radius increases. Radius is nothing but the distance between the nucleus and the outermost electrons. Next one is the metallic property. Okay. What is meant by metallic property? The metals always lose the electrons. So that we call it as a metallic property. So in a period, the metallic property of the elements decreases from left to right. Okay. So now as we know that, so the sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and the argon. So now in this case, so we are taking the third period. So sodium, magnesium, aluminium is metals. So when we are moving to that, the slowly the metals becomes a metalloid and it becomes the non-metals because because as the metals are always losing the electrons. So but once we are moving from left to right in the periodic table, so the element starts gaining the electron to complete the outermost shell. So the non-metallic character will come. The non-metallic character will come. Okay. So now here sodium, magnesium, aluminium are the metals. The silicon is the metalloid. So what is meant by metalloid? Because the transition from metals to the non-metals. So it will show the metals as well as the non-metals character. So that's why we call it as a metalloid. Then after silicon, phosphorus, sulfur, chlorine, argon. So those and all we call it as a non-metals. In a group, the metallic property of the elements increases from the top to bottom. So we are taking the group 6A, carbon, silicon, germanium, tin and the lead. So actually the non-metals, so carbon is the non-metal, then it becomes a metalloid, then it becomes a metal. So when you are moving down the group, the metallic property increases. When you are moving from left to right in the period, the metallic property decreases. Then non-metallic property. Non-metallic property means how it is easy to gain the electrons. So anyway, as we know that the metals are always losing the electron. So in this case, so the non-metallic property increases from left to right because we know that all the non-metals are placed in the right hand side in the periodic table. Okay, so the metals and then metalloid and the non-metals. So slowly the non-metallic property increases from left to right in the periodic table. So this is the most non-metallic character. It will gain the electrons easily. So and it becomes easily the negative ions. That's why we call it as electronegative nature. In a group, the non-metallic property of the elements decreases from top to bottom. The same example. So we are taking the group 6A, carbon, silicon, germanium, tin, lead. So the carbon is the non-metal, silicon is a metalloid, germanium is a metalloid, tin metal, lead metal. So when you are moving down the group, the non-metallic character decreases. So when you are moving from left to right in the period, non-metallic character increases. Hello. Now, this is from the questions from periodic classification of the elements. So these are all the questions from the year 2008 CBSE exam. So question number one. The elements of the second period of the periodic table are given below. Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So give reason to explain why atomic radii decreases from lithium to the fluorine. Okay, so now they have asked you why the atomic radii decreases from lithium to fluorine. So what is meant by atomic radii? So it is defined as the distance between the nucleus and the outermost electrons. So now lithium, beryllium, boron, so all are in the same periods. So the electrons are added in the same shell. So the distance between the nucleus and the outermost electrons are not varying. And also the pulling of the electrons towards the nucleus will also increase. So it is because the nuclear charge increases. Yes. So what is meant by nuclear charge? The number of the protons which is present in the nucleus that will get increases by due to the increase in the atomic number. Say for example, the lithium is having a 3 and the boron is having a okay, so the lithium is having the 3 and the beryllium is having the 4. So the lithium is having the 3 protons and the beryllium is having the 4 protons. So the number of the nuclear charge increases, but the distance from the nucleus and the outermost shell electrons is decreasing, not decreasing, it remains the same throughout the same period. So the force of attraction between the nucleus and the valence electrons increases. So effective nuclear charge increases, hence the atomic radii decreases from lithium to the fluorine. The next question, identify the most metallic. Okay, so which one is the most metallic? Lithium, because the lithium is having one electron in the outermost shell, so it can easily lose it. So one which is losing, so that we call it as a metal. So lithium is the most metallic element. Non-metallic element, definitely the one which can able to gain electron fast. That means the electronegative character. So the non-metallic element is F because it can able to gain electrons easily. So due to the very smallest atomic size. Okay. Second question. So the elements of the third period of the periodic table are given below. So period 3, sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. Okay. So the first question is, which atom is bigger, sodium or magnesium? Why? Okay. So now they are asking which atom is bigger. It's a sodium or magnesium. So sodium is bigger than the magnesium. Why? Because so the atomic sizes of the sodium is high because the distance between the nucleus and the outermost electrons is the same over here for the because it's having only the two shells. Magnesium is also having the two shells, but the effective nuclear charge increases, so there is a shrinking takes place, so the atomic size decreases. So because of that, the sodium has a bigger atom, lesser nuclear charge, so there is less force of attraction between the nucleus and the valence electrons. So there is a less effective nuclear charge. So it is therefore bigger in size. So the next one is the sodium is the, okay, identify the most metallic. Yes, and the non-metallic element in the period 3. The most metallic is the sodium because it's having only one electron in the outermost shell, so it can easily lose the electron. So due to its larger atomic size. So the chlorine is the most non-metallic element because it can gain electrons easily due to its smallest atomic size. So next question. So the short answer type from the year 2008. So the next one is question 3. The position of the three elements A, B and C in the periodic table is shown below. Okay. So the group 16 we are having a B over here, C, A and C. Okay. Giving reasons, explain the following. Element A is a non-metal. Okay. So the A is a non-metal. Why? Because it can easily gain electron because it is present in the group 17. So it's having a 7 electrons in the outermost shell. So it needs one electron to complete the outermost shell. So it can easily gain the electrons. So 7 valence electrons. So it is easily form the negative ion. So one which is gaining, that we call it as a non-metal. So element A is the non-metal. Question number B. Element B has a large atomic size than the element C. Okay, so now the element C is having the large atomic size because the period is different. So this is present in the period 2 and this is present in the period 4. So once you are moving down the group, the number of the shells increases. So the compared to the A, the C is having the more number of the shells. It's because the B is having the lesser atomic number, so the less nuclear charge and the less force of attraction between the valence electrons, and the nucleus, therefore it has the larger atomic size. Next one is element C has a valency of 1. Okay. Yeah, because the C is present in the group 17. It's having 7 electrons in the outermost shell. It needs one more electron to complete the a stable outermost configuration. So the valence electron is 7, so it needs one more. So it gained one electron to become the more stable. So its valency is equal to the 1. Next question. The position of the three elements A, B and C in the periodic table is shown below. Okay, so the group 1, the B is present, group 17, the A is present, group 16. Okay, element A is a non-metal. Yes, again the same answer because it's having the 7 electrons in the outermost shell, so it can easily gain the 1 electron, and so it is a non-metal. Atom of the element C has a larger size than the element A. Yes, so because as the it is present in the period 2, it means that it's having only the 2 shells. So it's present in the period 3. So the period indicates always the number of the shells. So the C is having the 3 shells. So the distance from the nucleus and the outermost electrons increases over here. So that is why it's a larger in size than the element A. Next question. Element B has a valency of 1. Yes, so the element B is present in the group 1. So the group 1 indicates that always the group number 1 indicates that how many electrons are present in the outermost shell. So here it is 1. So the 1 electron is present in the outermost shell. So the element B can easily lose the 1 electron and it forms the stable configuration. So its valency is 1. Next question number 5. So what physical and chemical properties of the elements were used by the Mendeleev in creating his periodic table? List two observations which posed a challenge to the Mendeleev's periodic law. Okay. So the atomic mass. So yes, what is the atomic mass? The atomic mass is nothing but the combination of the protons and the neutrons which is present in the element. So it is a physical property and the nature and the formula of an oxide and the hydride formed. the chemical property was used by the Mendeleev. So the following are the two observations which posed a challenge to the Mendeleev's periodic law. So the increasing order of the atomic weights could not be maintained while matching the chemical properties. So the chemical properties do not depend upon the atomic masses. Yes, so what he has done over here is when the atomic weights are increasing, so he is not matched up with the chemical properties because it's changing. So that is the challenge which is faced by the Mendeleev. And one more thing is the isotopes have the different atomic mass but having the same chemical properties. Yes, because in those days the neutrons are not yet discovered. So that is why. So the isotopes means the what is meant by isotope? Isotope is nothing but same atomic number but different mass number. So the atom is having the, so say for example, chlorine. Chlorine is having a atomic number 17, but the mass number we are having 35 and 37. So uh, because of the change in the neutrons, the different number of the neutrons. So the isotopes are having the same different atomic mass, but the same chemical property. So this is the another challenge because the one of the what is that particle, the neutrons, which that time they have not yet discovered. So this is the two challenges faced by the Mendeleev. Next one is question number 6. Okay, so now here they have given some of the elements which is present in the periodic table. Okay, so the first question is, they have not given the first question itself. Okay, so the atomic size of the magnesium is less than that of the sodium. Yes, so magnesium is present in the group 2 and the sodium is present in the group 1. So because the magnesium is having the more effective nuclear charge, it's having the 12 protons and the sodium is having the 11 protons. So the attraction will be higher over there in the magnesium, but in the case the sodium is having the less attractive force, that is the less effective nuclear charge. So that's why the sodium is having a atomic size bigger than the magnesium. Fluorine is more reactive than the chlorine. Okay. Fluorine is more reactive than the chlorine. Okay. The fluorine is present in the period 2 and the chlorine is present in the period 3. And also the atomic size is decreases in the fluorine compared to that of the chlorine. The fluorine can easily form the F minus more easily than chlorine because of the smaller atomic size. So the F minus is more stable than the Cl minus. Therefore, the fluorine is more reactive than the chlorine. Question number 7. Why do we classify the elements? Okay, so now it is done so to study the properties of the elements conveniently. Yes. So for example, if I give you the group, suppose the element, if you know that what is the group and the period in which the element is present, so we can able to tell that how many number of the protons present, electrons, neutrons, and how many electrons are present in the outermost shell, what is the electronic configuration, what is its valency, whether it is a metal or the non-metal or the metalloid, whether it will lose the electron or gain the electron. So what is this property? Something we can able to say about. So that is why we are classifying the elements. Easy to study about the properties of the elements. Second question. What were the two criteria used by the Mendeleev in creating his periodic table? Yes. So increasing, yeah, he has used the increasing order of the atomic mass and the similar in the chemical properties. So these two things only he has used to arrange the elements in the periodic table. In the Mendeleev's, okay, why did Mendeleev leave some gaps in his periodic table? Because that gaps were left for the undiscovered elements. So all the elements were not discovered at those times. Only few elements were discovered. So wherever the place he has got it, similar chemical properties, he placed the elements in that space. So if it does not match or something, so he left some spaces for the undiscovered elements. In Mendeleev's periodic table, why was there no mention of the noble gases like helium, neon, argon? Yes, there is a no, they were nowhere mentioned in the Mendeleev periodic table for the noble gases because they have not invented at that time. Would you place the two isotopes chlorine Cl35 and Cl37 in the different slots because of their different atomic masses or in the same slot because their chemical properties are the same? Justify your answer. Okay, so actually we know that the Mendeleev used the two things. One is that based on that chemical properties he classified the elements and based on the um atomic mass he classified. Now in this case the chlorine is having both are chlorine atom. Both are having a same chemical properties but they are having a different mass. So they will keep it at the same slot because as they have the same chemical properties according to the Mendeleev's periodic table. Okay, next one. So these are all the questions from the year 2009. So the first question, lithium, sodium and potassium form a Dobberne's triad. The atomic masses of the lithium and the potassium are 7 and 39 respectively. So predict the atomic mass of the sodium. Okay. So now according to this Dobberner, so the lithium which is present before the sodium, potassium is present after the sodium. So he has taken the average of these two. So 7 plus 39 divided by the 2. So 46 divided by 2 gives 23. So 23 is the atomic mass of the sodium. Next question. Chlorine, bromine and iodine form a Dobberne's triad. The atomic masses of the chlorine and the iodine are 35.5 and 126.9 respectively. So predict the atomic masses of the bromine. So atomic masses of bromine is here also the same thing. So bromine, chlorine, bromine and the iodine. So what they have done is, so they have given the chlorine and the iodine atomic masses. So we have to predict the bromine. The same thing we have to follow. We have to take the average of these two. So 35.5 plus 126.9 divided by the 2. So 162.4 divided by 2 which gives 81.2. So this is the atomic mass of the bromine. Next question. Why was the system of the classification of elements into the triads not found suitable? Yes, it is because all the elements discovered at the time could not be classified into the triads. Okay, next short answer type from the year 2009. State Mendeleev's periodic law. Write the two achievements of the Mendeleev's periodic table. So the Mendeleev's properties of the elements or the periodic functions of their atomic masses. Achievements, it could easily all the elements discovered at the time and it helped also in the new elements. It also helped in the correction of the atomic masses of some of the elements. So these are all the achievements. So we can say that he has given some shape to the periodic table. So he would have given a very good periodic table because some of the elements are not yet discovered at the time. But he has done a very good job to make a periodic table. Then very short answer, 3 marks answer from the year 2009. So what is mean by the periodicity? So the repetition of the same properties after the definite interval is called the periodicity in the properties. So why do all the elements of the same group have the similar properties? Because they are having the same number of the outermost shell electrons. whether it has to give one electron in all the elements, it has to lose only one electron. That's why. It is because the same valence electrons, therefore it's having the same properties. How will the tendency to gain electrons change as we go from left to right across a period y? Okay, so the gaining of electrons from left to right. So the left we are having a metals, the right we are having the non-metals. So the left always losing the electron, the right always gaining the electron. Okay, so the tendency of gaining the electrons increases from left to right in a period because the atomic size goes on decreasing and the effective nuclear charge increases. Question number 13. So what are groups and the periods in the periodic table? Okay. So what are groups? The groups is nothing but the vertical column in the periodic table. So horizontal rows we call it as a period. Next one. The two elements M and N belong to the group 1 and the group 2 respectively and are in the same period of the periodic table. How do the following properties of the M and the N vary? Okay. So M and N are present in the group 1 and the group 2. So it means that M is having one electron in the outermost shell and N is having the two electrons in the outermost shell. Okay. Sizes of the atom. Okay, so now what will happen? M and N belong to the same period, but the groups are different. That is group 1 and the group 2. So the N will be smaller compared to that of the M because the atomic size goes on decreasing when you are moving from left to right in the periodic table. Next one is their metallic character. So as we know that all the metals are placed in the left hand side of the periodic table. So once you are moving from left to right in the periodic table, so the metallic size decreases. So the sodium is more metallic character than the magnesium. So the next one is their valencies in forming the oxides. Okay, so here the valency of the mm, M is 1 because it is present in the group 1 and N is 2 electrons, right? So the valency is increasing first and then decreases. So the valency is for the M is 1 and the N is 2. So it will start moving increasing from group 1 to 4, then it will start decreasing. Then the next question. Molecular formula of the chlorides. So molecular formula of the chlorides is so MCl because the chloride is having the -1 charge. So M is having the +1 charge. So +1 and the -1. So both the charges are the same. So you will be getting the MCl. So the next one is N. Okay. So N is present in the group 2. So it is having the +2 charge, but the chlorine is having only the -1 charge. So we need to add one more chloride ion to make the charges equal. So NCl2. So this is +2, this is -2. So these are all the molecular formulae of their chlorides. Next one is question number 14a. Which two criteria did Mendeleev use to classify the elements in the periodic table? So one is that atomic mass, the another one is the chemical property of the elements. So based on these two properties, so the Mendeleev classified the elements. State Mendeleev's periodic law. So the properties of the elements are the periodic functions of their atomic masses. Next question. Their valency, okay. Okay, so why could no fixed position be given to the hydrogen in the Mendeleev's period?
Hello?
Yeah.
Ma'am, I believe we already covered this question in multiple short answer questions, I think, right?
Yeah, MCl, NCl2 are the
Yeah. Can we
formulas.
move on to the next question?
Yes, once again. This one?
Yeah, we also covered, I think. This one also, second also.
Yeah. Okay, this one is not covered, right?
Yeah.
Okay. So this question is from the year 2010. The atoms of the seven elements A, B, C, D, E, F, and G have a different number of electronic shells but have the same number of the electrons in the outermost shell. Okay, so it means that it's having the same group because it's having the same number of electrons in the outermost shell. The elements A and C combine with chlorine to form an acid and a common salt respectively. So the oxide of the element A is liquid at room temperature and is a neutral substance, while the oxides of the remaining six elements are basic in nature. So based on the above information, answer the following questions. What could be the element A, B? Okay. So now, will elements A to G belong to the same period or the same group of the periodic table? Okay, the first question is what could be the element A? The element A can able to combine with the chlorine and it forms the acid. Okay, so always the metals can able to only forms the basic. The non-metals only will form the acidic in nature. And also the oxide of the element A is liquid at room temperature and is a neutral substance. But while the oxides of the remaining six elements are basic in nature, so it means that the metals are always forms the basic character and the non-metals are also having the acidic character, but this one is having the neutral one. So the element A will be the hydrogen because when it is combines with the oxygen, we are getting a liquid. And also one more the thing, it forms an acid. So it's a HCl, hydrochloric acid is formed. So based on these informations, we have found out the A is nothing but the hydrogen. Next question. Will elements A to G belong to the same period or the same group of the, okay. So now yeah, this we have already same number of electrons in the outermost shell. It means that it's a group. So it belongs to the same group of the periodic table having the same number of the valence electrons. Next question. So write the formula of the compound formed by the reaction of the write the formula of the compound formed by the reaction of the element A with the oxygen. Yes, that is H2O, right? Because the A is the element hydrogen. So when it is combining with the oxygen and it forms the A2O. So the formula of the compound, right? So it is A2. Show the formation of the compound by the combination of the element C with chlorine with the help of the electronic structure. Okay. So the formation of the compound by the combination of element C. So C is giving one electron because this present in the group 1 because the hydrogen is present in the group 1, so it's having a one electron in the valence shell. So the C is always, when you are moving down the group, the metallic character increases, so it will lose the electron easily. So the C, the element C can easily donate the electron, and the chlorine atom easily gains the electron and it forms the chloride ion. It forms the C plus and the Cl minus. So this is the ionic compound. So what would be the ratio of the number of combining atoms in a compound formed by the combination of the element A with the carbon? Okay, so element A with the carbon. Okay. Element A is having a one electron in the outermost shell, so it's having the valency is the 1. Carbon is having the valency is the 4. So we need to do the cross multiplication. So the ratio will be A4C. So that because the ratio is 4 is to 1. So what would be the ratio of the number of combining atoms in a compound formed by the combination of the element A with carbon. Uh, Okay, the ratio is 4:1, so already we have given over here. Yeah. So which one of the given elements is likely to have the smallest atomic radius? So definitely the A is having the smallest atomic size, because when we are moving down the group, the atomic size increases due to the increase in the number of the outermost shell. Okay, next question. Question number 17. So in the following table, the six elements A, B, C, D, E and F of the modern periodic table with the atomic numbers 3 to 18 are given below. Okay. So which of these halogen is a noble gas or a halogen? Okay, so they have given some of this, and so the G is present in the group 18. So this is present in the last column. So this we call it as a noble gas. So G is present in the last column, so it's a noble gas. So before that, it's a group 17. We call it as a halogen. So F is a halogen. F is a halogen, and G is the noble gas, because here all the electrons on the outermost shell are completely filled over here. If the B combines with F, what would be the formula of the compound? Okay, so the B is having a 1, F is having the 1, so 1 charge, so it forms the BF. Write the electronic configurations of the C and the E. So the C has the atomic number 12 and the electronic configuration is, so the first shell is K. So K will occupy the two electrons. The second shell we call it as L. So the L will occupy the 8 electrons. The third shell will occupy the 2 electrons. Then E has the atomic number 8 and the electronic configuration is, so the 2 will split up into 2, 6. So the first shell is K, so it will occupy the 2 electrons. The second shell is L, so it will occupy the 6 electrons. So in the following table are given 8 elements A, B, C, D, E, F, G and H of the modern periodic table with the atomic numbers of the elements in the parentheses. Okay. So now, what is the electronic configuration of the F? So the F is having the atomic number 12. So first 2 electrons we have to give in the first shell, then 8 electrons, then 2. So 2, 8, 2. What is the number of the valence electrons in the atom of F? So the valence electrons are nothing but how many number of the electrons which is present in the outermost shell. So it's having the configuration 2, 8, 2. So 2 is the valence electrons for the F. What is the number of the shells in the atom of the fluorine? So there are 3 shells in the F, because the electrons occupied, this is in the first shell, second shell and third shell. So it contains the 3 shells. Write the size of the atoms of E, F, G and H in the decreasing order. Okay. So now we have to see where the E, F, G and H. So E is present in the group to E, F, G and H. Okay. So there will be increasing in the outermost shell for all the atoms. So H will have the more number of the size, then G, then F, then the E. So the decreasing order of the size of the atoms. Right? State whether the F is a metal or the non-metal. So as it is present in the group 17, so definitely the metallic size decreases from left to right in the periodic table. So the F, so in this case, the F is present in the group 1, so it is a metal. Out of the 3 elements, Out of the three elements, one second. Yeah. Out of the three elements, B, E, and F, which one has the biggest atomic size? Okay, B, E, F. So B, E, F. So which one is having the biggest atomic size? So B is having the biggest atomic size among the B, E, and F. Because it is present in the third period, so it is having the three shells. But the E is present in the group 2, it's having only the two shells. So compared to the E, the B is having the more number of the shells, so the atomic size increases. Then we have to compare the B and the F. So both are present in the same period. So it's having the same number of the shells. So it's having also three shells. This is also having the three shells. But in this case, the nuclear charges increases. In this case, it's less effective nuclear charge. So the pulling of the electron will be decreased over here. So it's having a bigger size.